Today we are going to be talking about multiplication law of probability. In the previous lesson we covered basics of conditional probability, and remember the formula for basics of for conditional probability. This formula I'm going to write it again because this formula is a formula you need to have in mind, because many other formulas actually derive from this formula for conditional probability. So given we have probability of A given B is equal to probability of A and B divided by the unconditional probability of B. Okay? This is the normal formula for conditional probability. Now, in this very short lesson, we are now going to understand how to use multiplication law of conditional probability. Multiplication law simply follows from this formula we've written. It helps us to find the conditional probability in this way. So we simply rewrite the formula by saying that probability of A and B happening is equal to the probability of A, conditional probability of A given B, times the unconditional probability of B. So again, if you interchange the positions of A and B, you also have the same result. So basically this is exactly the same as, I'm going to use another color of pen this time. Let me use red. So this is the same as saying that probability of A and B is equal to probability of B given A times the unconditional probability of A. Remember, in the first lesson we discussed something called the laws of probability, and we talked about the commutative law. Yeah, the commutative law simply says, I think that should be the associative law, says that A and B is equal to B and A. Okay, so when we say A and B here, we can also write it as B and A. Alright, so I'm trying to make sure that you know the basics and you are not missing out anything. So now this is the multiplication law, or part of the multiplication law at least for now. Let's now take an example to illustrate this. So I'm going to change my pen to black. So we have a bag contains red balls, 3 red balls and 1 blue ball. 2 balls are selected without replacement. What is the probability that both balls are red? So we have a bag containing 4 balls, 3 red, 1 blue. 2 balls are selected without replacement. What is the probability that both balls are red? So this covers what we are trying to discuss about conditional probability and also multiplication law. Let's now use the notations to indicate it. Let me rule out this one. Fine. So first we have that let R1 be the probability or be the event that the first ball is red. Events that first ball is red. So this is actually event that first ball is red, not probability. RT be the event that the second ball is red as well. So R2 that the second. So how do we approach this point? So it means that we can now have probability, the unconditional probability that the first ball is red, okay? And we can also have the unconditional probability that the second ball is red, okay? These are just notation. And we want to find that the 2 balls are red. So we want to find probability of R1 and R2. So in this case now, we can use the principle of conditional probability to rewrite this formula when we already have R1, probability of R1, probability of R2, and R1 and R2. So let's proceed. So we now have that probability that R1 is red. Remember that red balls are how many? There are 3, blue, 1. So total balls is 4. So probability that the first ball is red is simply 3 over 4, right? 3 over 4. This is very clear. Now, when you take out the first ball and we have only 2 more red balls there, then we have 2 red balls and 1 blue ball. So probability that R2 is red will have to be a conditional probability that R1 is red. So in this case, if we are calculating probability that R2 is red, given that R1 is also red, because we've taken out 1 red ball, it will now be, how many red balls remain? It remains 2 red balls, and the total number of balls is now 3. So you have 2 over 3. Right? Good. So in this case, we can now use the formula for multiplication law to find the probability that R1 and R2 are both red. So probability that R1 and R2 is equal to probability that R2, given that R1 is red, times the probability of what? R2. Probability of R2 given R1, probability that times the probability of R1, right? So this will simply give us 2 over 3 times unconditional probability of R1 is calculated as 3 over 4. And that will give us 1, 2, which is 1 over 2. So you can see how interesting probability theory can be. Now we apply the multiplication law of probability, and also we apply the law of conditional probability. And we now have probability that both balls are red is given by half, 1 over 2. Let's take another example. In this case, we want to use, assuming that if a weather is cloudy, the probability that it will rain is 0.3. Also, the probability that it is cloudy, PB, is 0.2. So at this point, I'm going to start a new screen. So let's just start a new screen. So let me shift this upwards. So we are saying that, assuming that if the weather is cloudy, then the probability that it is raining A is 0.3. So, and the probability that it is cloudy is 0.2. So let's say A is equal to events that it is raining, and B is equal to events that the weather is cloudy. Okay, so probability that it is cloudy we are given unconditionally to be 0.2. And now we have the probability that it is raining given that the weather is cloudy is 0.3. So we have probability that it is raining given that the weather is cloudy is equal to 0.3, right? So we can now calculate probability that it is cloudy and raining at the same time. So it's probability that it is cloudy and raining at the same time is equal to probability that it is raining, given that the weather is cloudy, times the unconditional probability that the weather is cloudy. So that is going to give us 0.3 times 0.2, and that is going to give us 0.6. So this is how to apply the multiplication law to solve simple probability problems. All right. In the next lesson, we now continue with total law of total probability. So try to make sure you don't miss out anything, because with time we are going to be getting close to more challenging things like the Bayes theorem. Actually, we've covered the basic things we need to know, and Bayes theorem will just be something that will just flow along from what we've been discussing so far. I'd like to remind you to subscribe to my channel, leave me a comment if there is something that you don't understand in this video, and we'll see in the next lesson when we are going to discuss law of total probability.